With the help of the James Webb Space Telescope, scientists have located the most remote active supermassive black hole to yet. Its black hole is smaller than any other one yet discovered in the early cosmos, and the galaxy CEERS 1019 existed just over 570 million years after the Big Bang. Additionally, two additional black holes that were smaller and existed 1 and 1.1 billion years after the Big Bang were also readily shaken out by them. 11 galaxies that date back to between 470 and 675 million years ago were also detected by Webb. Webb's Cosmic Evolution Early Release Science CEERS survey, directed by Stephen Finkelstein of the University of Texas at Austin, supplied the proof. Not only is CEERS 1019 notable for how old it is, but it is also notable for how little its black hole weighs. This black hole is far smaller than other black holes that were also present in the early cosmos and discovered by other observatories. It has a mass of only 9 million solar masses. They are easier to find because of their greater brightness, because they typically contain more than 1 billion times the mass of the Sun. The black hole in CEERS 1019 resembles the Milky Way galaxy's black hole more closely, which has a mass 4.6 million times that of the Sun. Additionally, this black hole is not as brilliant as the previously discovered behemoths with greater mass. Even though it is smaller, this black hole has been there for such a long time that it is still unclear how it came to be so soon after the universe's creation. Smaller black holes must have existed earlier in the cosmos, as scientists have known for a long time, but it wasn't until Webb started monitoring that they were able to make certain discoveries. These researchers were also able to precisely determine the distances of early universe galaxies and, consequently, their ages thanks to Webb's sensitive spectra. Seiji Fujimoto of the University of Texas at Austin and Pablo Arrabal-Haro of the NSA's NOIR lab worked together to identify 11 galaxies that were in existence 470 to 675 million years after the Big Bang. Not only are they far away, but it is noteworthy that so many brilliant galaxies were found. Webb would likely find fewer galaxies than are now seen at these distances, according to research. Arrabal-Haro exclaimed, "I am astounded by the amount of incredibly precise spectra of distant galaxies Webb returned. These data are astounding beyond belief. These are simply the survey's initial groundbreaking results." According to Finkelstein, up until recently, most research on things in the early cosmos was theoretical. We can now begin to precisely measure black holes and galaxies thanks to Webb, in addition to seeing them at great distances. That is the telescope's incredible power. Future studies may also reevaluate models of how black holes developed and grew throughout the first several hundred million years of the universe's existence, using Webb's findings to explain how early black holes created.